Alright, welcome back to Dr.Whee math tutorial class. Today we'll be learning about LCM, least common multiple, and how to find them. Okay, so let's define what least common multiple is first. It is the smallest common multiple. It's a number, right, of two or more set of numbers. Okay, basically what it is a common number, the smallest common number, in which two or more number can divide into. Alright, so let me give you an example. I think it's better if I give you an example and it makes more sense. Let's look at number 4 and 6. Okay, what is the least common multiple of 4 and 6? In other words, a number where 4 can divide into it and 6 can divide into it, but it's the smallest of the two that's common. Okay, so in order to illustrate this, let me show you that if we multiply 4 by its natural number and 6 by a natural number, and then we'll find a common multiple in each of the pattern. Okay, so 4 times 1 give you 4, 4 times 2 give you 8, 4 times 3 give you 12, 4 times 4 give you 16, and let's do two more. 4 times 5 is 20, and 4 times 6 is 24. All right, let's do that. 4 times a natural number, 1, is 6, times by 2 is 12, 6 times 3 is 18, 6 times 4 is 24. Now if you look at the set of numbers here, you'll notice the least common multiple where the 4 and 6 get into is actually 12. You see, 4 can get into 12 and 6 can get into 12. 4 cannot get into 6 and 6 cannot get into 8. 4 cannot get into 18 and 6 cannot get into 20. There's another common multiple is 24, right? So 4 can get to 24 and 6 can get into 24, but it is not the smallest common multiple. 12 is. Alright? So I'm going to show you a way to figure out the least common multiple. I'm giving you examples, and I'll show you the step on how to solve these set of questions. Okay, so how to figure out the least common multiple. So let's look at this first question. Find the least common multiple of 24 and 36. So what are the steps to figuring this question? The first step is to break down the number into its prime factors. Okay, so break the number into its prime factors. Right, so let's do that. So it's going to be 12 and 2, and break down 12 into 6 and 2, and then 6 is 3 and 2. So notice the prime factors are 3, 2, and 2. So 3 times 2 times 2 times 2. And let's do that. Okay, so 6 times together we'll get 36, and break 6 down to its prime factors. Okay, so we have a 3, 3, 2, 2, so 2 times 2 times 3 times 3. There we go. We have a prime factors for 36 and prime factor for 24. The next step is to circle the great prime factor product in the set of numbers. Okay, the great prime factor. So you notice here the greatest prime factor for 24 is the product, right, of 24 is 2 times 2 times 2. As well, you notice on this side the greatest common prime factor product is 3 times 3, right? So 2 times 2 times 2 times 2 is the great prime factor for this number here. And for this number is 3 times 3, okay? Because you have 3 here, but there's 3 times 3, so the greatest prime factor product. Same here. We have 2 times 2 here, but we have 2 times 2 times 2 here, which is the greatest prime factor product there. So now all we have to do is multiply these two set of prime factor product together. So we have, this is 8 and this is 9. 9 times 8, or 8 times 9 is 72. So this would be the least common multiple of 24 and 36. Alright, so remember the steps. Break the number into its prime factors. Circle the great prime factor product. Okay, so for this number 24, if you look through and compare that to 36, 2 times 2 times 2 is the great prime factor product. And then for number 36, it would be 3 times 3. Okay? Alright, let's do another question. So let's have a look at this here. We have 450 and 600. We want to find the least common multiple of these two numbers. Let's break down its prime factors first. We have 45, 10. 10 can be broken down to 5 and 2, and 45 can be broken down to 9 and 5. 9 times 5 is 45, and 9 can be broken down further to 3 times 3. So the prime factors for 450 is the following. Right, we have a 2, 3s, and then we have 2 5s. Okay, so 2 times 3 times 3 times 5 times 5. This is the prime factors for 450. Look at 600. We have 6. Its prime factor is 3 and 2, and 100 is 10 times 10, and the prime factor for 10 is 5 times 2 and 5 times 2. So the prime factor for 650, we have 2, 2, 2, 3, and then 5, 5. So 2 times 2 times 2 times 3 times 5 times 5. Now the next step is to look for the great prime factor product. So if you look at 5 times 5, that is found in both, so they are the greatest, right? The great prime factor product. And the next thing is 3 times 3. We have only one single 3 here, but we have 3 times 3 here, so that's another prime factor product. That's the greatest compared to the 2. And then we also have this great prime factors, because we have 2 here, but we have 2 times 2 times 2, which is the greatest prime factor product. So now we have these 3 set of prime factor products. We're going to multiply them together. So 3 times 3 is 9, and then 5 times 5 is 25, and 2 times 2 times 2 is 8, and you multiply 9 times 25 times 8, and that will give you 1800. Okay, so yes, the 1800 is the lowest or least common multiple of 450 and 600. Okay, let's do some more question. Alright, let's do another 2 set of numbers. So we have 220 and 620, and let's find the lowest common multiple of these 2 numbers. Let's break this down, right? Remember, the first step is to break down to its prime factors. Okay. There we go. So the prime factor for 220 is 2 times 2 times 5 times 11. Those are the prime factors for 220. Okay. Now for 620, right? The prime factors for 620 is 2 times 2 times 5 times 31. So the next step is to find the great prime factor products in these 2 numbers. And if you look at here, 2 times 2 is a great prime factor product. Then 5 is also that as well, because you notice here we have single 5s. Okay, now here's where it's kind of harder to understand, but here we have a unique 11 and we have a unique 31. It is the greatest factor that's unique to the set of numbers, so that is considered as the great prime factor, although the product is itself. Okay, it has to be 11 and 31. So multiply everything together. What do you get? Well, okay, so 2 times 2 is 4 times 5 is 20, and then times 11 times 31. Now you can take out your calculator, okay, and that'll give you 6,820. That is the least common multiple for 220 and 620. See, it can get quite complicated, and the least common multiple can get quite big. Alright, let's do maybe one more. Right, now we have 3 numbers. We want to find the least common multiple of 24, 36, and 50. Again, first step is to break down into its prime factors. So I would circle the prime factors, make it easier to make it more visible. So we have for 24 is 2 times 2 times 2 times 3. It's the prime factors for the 24. 36, okay, can be broken down to 6 and 6, and then 6 and 6 can be broken down to its prime factors. 3 times 2, 3 times 2. So the prime factors for 36 is 2 times 2 times 2 times 3 times 3. Okay, this is the prime factor products of 36. And we have 50. And we can broke down to its prime factors. Again, the prime factors product would be 5 times 5 times 2. Okay, so here we have 3 numbers and its prime factors product. And you notice for the great prime factors product, the greatest one for 2 prime factors is 2 times 2 times 2. For 3, it would have been 3 times 3, right? We have 1 here, but we have 2 here. And for 5s, 5 times 5. So 2 times 2 times 2, that's 8. 3 times 3 is 9. 5 times 5 is 25. Group them together, so 8 times 9 times 25. Okay, so 25 times 8 will give you 200, times 9 is 1800. There we go. So the least common multiple of 24, 36, and 50 is 1800. Alright, let's do a bonus! Okay, so let's try the last 3 numbers, 45, 100, and 220. That gets pretty big now, right? So what is the least common multiple of 45, 100, and 220? Well, again, we got to break it down to its prime factors. Okay, so 45 is 3 times 3 times 5 for its prime factors product. 100 is 10 times 10, and 10 can be broken down to its prime factors of 5 and 2, and its prime factor products is 2 times 2 times 2 times 5, oops, times 5. And for 220, we can break it down to 22 and 10, and then 22 can be, the prime factor is 11 and 2, and 10 is 5 and 2. So again, I should circle it to show you the prime factors. There we go. It's usually at the end node of a tree diagram here. So we have here, again, I usually list them from the smallest number to biggest prime factor numbers, right? Sometimes I forget, but anyway. Okay, so you see here that we have a prime factors product. We want to find the greatest prime factor product. So starting with 2's, okay, so it seems like 2 times 2, right, is the greatest prime factor product. And then we have a 3 here, 3 times 3, and then 1 5, but 5 times 5. Okay, so that's the great prime factor product. And then we have a unique 11. So that's considered as the great prime factor, although it's not really a product unless you multiply by 1. But anyway, so that's 11. So we'll consider that. And then we're going to multiply all these set of numbers together. 3 times 3 is 9. 5 times 5 is 25. 2 times 2 is 4. And then we have 11. So we're going to multiply these 4 numbers together. Notice this is 100. 9 times 100 times 11. You get 900 times 11 is 9,900. Wow, big number. Okay, so 45, 120, 220. The least common multiple is 9,900. And there we go. And that's how you do least common multiple questions.